This is number 22 on page 495, where we're asked to find all 6 of the 6th roots of -1. Well, using real numbers, you cannot take even roots of negative numbers. They do not exist. If you tried to do this on your calculator, you would get an error message. All 6 of these 6th roots are going to be complex numbers, x plus y, j. So the first thing we want to determine is the value of n, r, and theta. Let's first identify that the number -1 is a real number. So it is the real number part of x plus y, j. There is no j in that number, so the imaginary part of that is 0. So this is the number -1 plus 0j if we're writing this complex number in rectangular form. If we picture this on the complex plane, that means go left 1 unit and don't go up or down. So we're on the unit circle here at 180 degrees. There's my theta. Clearly, the distance of that point from the center of the circle is 1. So my radius is 1. And n is the value of the roots that we're finding, and we're finding the 6th roots, so n is 6. So, the first thing we need to do is determine what our formula looks like when we substitute those values into that formula. Assuming k is 0, we always start with k equal to 0, we need the nth root of r, the 6th root of 1. If I substitute 0 in for k there, 360 times 0 over n is going to be plus 0. So my first value is just going to be the cosine of theta, 180, over n, 3, plus I times the sine of the same, and that's 60 degrees. Now this time we recognize 60 degrees as one of our unit circle values. On the unit circle at 60 degrees, we know our x-coordinate or cosine is 1/2. Our sine, the y-coordinate, is square root 3 over 2. So the 6th root of 1 is 1. The cosine is the x-coordinate, and the sine is the y-coordinate. So my first 6th root is just 1/2 plus I root 3 over 2. Now I want to determine how much I'm going to add to that previous angle measure of 60 degrees, and this is where I focus in on this portion of the formula. Substituting 1 in for k, which would be the next value of k after 0, 360 times 1 is 360. Divide by n, which is 6. 360 divided by 6 is 60 degrees. All angles that I use to determine these 6th roots will be 60 degrees apart from one another. So for z sub 1, I'm going to need to take the 6th root of 1 times the cosine of my previous angle measure, which was 60, plus 60, 120 degrees. I recognize 120 degrees as an angle on my unit circle. Its x-coordinate is -1/2, and y-coordinate is square root of 3 over 2. So the cosine, -1/2, the sine, square root of 3 over 2, times I. There's my second 6th root of -1, excuse me. My third, I'm going to need to add 60 degrees to my previous angle measure. Well, my previous angle measure was 120. If I add 60, I'm at 180 here, where I know the coordinates are -1, 0. The x-coordinate is always the cosine. so it's negative 1, plus I times the y coordinate, which is 0. I times 0 is 0. So you can write it as negative 1 plus 0i, or 0j, or you can just write it as negative 1. My fourth sixth root is going to be using an angle 60 degrees more than the previous. That's 240. At 240 degrees, I know that my sine is negative 1/2, and my cosine is negative 1/2, and my sine is negative root 3 over 2. So it's negative I root 3 over 2. To find my fifth root, I'm going to need to add 60 to my previous angle measure of 240. That lands me here at 300, where I know the cosine is positive 1/2 and the sine is negative root 3 over 2. And of course the sine is always multiplied by I or j. And my last sixth root of z will be, not z sub 6, but z sub 5, will be 60, using an angle 60 degrees more than the previous. Well, the previous was 300. Add 60. Now we're at 360. And at 360 degrees, we know the coordinates are 1, 0. So the cosine is 1. The sine is 0. So you can write that sixth root of negative 1 as 1 plus 0i, or you can just identify it as 1. So the sixth roots that we got were 1/2 plus I root 3 over 2, negative 1/2 plus I root 3 over 2, negative 1 plus 0i, or just negative 1, negative 1/2 minus I root 3 over 2, positive 1/2 minus I root 3 over 2, and finally 1 or 1 plus 0i.